Let's review a few terms before we move on. First, we want to review angular velocity. When we talk about angular velocity, our symbol will be a lowercase omega, which kind of looks like a W. And it's defined as the angular displacement per unit time. And the units for angular velocity are in terms of radians per second. When we calculate angular velocity, we would take the angular displacement, and that would be in terms of radians. So if we're given it in terms of revolutions, we'll need to convert that to degrees and then to radians, divided by time, since angular velocity is a rate. Let's also review tangential velocity. The speed of an object in rotational motion when it's let go is considered the tangential velocity. The object will go off tangent to the circle when it's released. So we need to remember what the word tangent means, and tangent is just a line that touches the circle at one point. The units for tangential velocity are meters per second. And our equation is v sub t, which is our tangential velocity, will equal the angular velocity times the radius. So when we talk about the tangential velocity, we're talking about an object that's moving in a circular pattern. And for some reason, the force holding that object in that circular pattern is released and the object flies off, and it'll go tangent to the circle at the tangential velocity. Now let's talk about the force that keeps an object moving in a circular motion. And to do that, we need to talk about centripetal acceleration. And this is an acceleration directed towards the center of a circle. The object must be accelerating when moving in a circle because its direction is always changing. And the tangential and centripetal accelerations are always perpendicular to each other or at right angles to each other. The units for centripetal acceleration are the same as any other acceleration, and that would be a meters per second unit. So when we talk about centripetal force, we're dealing with a force that keeps an object moving in a circle. It's directed towards the center of the circle or towards the axis of rotation. And if that centripetal force is removed, the object flies off tangent to the circle. So the centripetal force is the force that holds an object in its circular motion. To calculate centripetal force, we're going to use the following equation. We need to make sure we watch our units, and we remember there's a difference between meters and radians. Forces are always in newtons, and mass is always in kilograms. So our equation for calculating centripetal force will be the mass times the tangential velocity divided by the radius of the circle.